Hi, this is Yutong, and I'm going to explain some question in our textbook. And the page is 924, and the question is 22. And before I talk about the question, I just want to say that I'm a Chinese and just come to the US for 2 years. So sometimes maybe you cannot understand my explanation, but I think my handouts, like what I write, is correct, and hope you can listen it. Okay, so let's talk about the question. So the question is fxyz equal to xy at yz at xz. So the point is 1 to -1, and the vector is equal to 2I at j minus k. And the question is to find the directional derivative. And okay, let's start with that. First of all, we have to find fx, x, y, z. Find the derivative about the x is equal to y at z. And fy, x, y, z equal to x at z. And x, z. Oh, this is f at z, x, y, z. Sorry, I made a mistake. Is equal to x at y. Okay, so it's all the derivative, and we know that the unit vector, the expression is equal to vector over the vector's magnitude. But according to the question, we just know the vector, but we don't know the magnitude of the vector. So we have to find the magnitude of the vector is equal to square, oh no, it's like the root 2 square at 1 square at minus 1 square is equal to that one. And we already know the magnitude of the v vector, so we have to find the unit vector. The unit vector is equal to 2 over that one. So I at 1 over the 6 square 1/2 j. Let's add the same number, but it's minus is k. Okay, remember that? And we gonna do, oh, I cannot do that, but so I'm sorry, I have to use a eraser. Use the eraser to get in half. And now we can go to the direct derivative. X, Y, Z, and we use that the first time we get the first derivative about the x is equal to y at z times the, and we get the unit vector. The first number, do you remember, is 6 square 1/2 and over 3, and minus x at z times the number at, sorry, I made a mistake because this is because this is minus, it's not. Y times the same number. Okay, so we get this expression also as like a function, but according to the question, we have the point 1 to -1. So the point is the question give us. And we go the answer, the directional derivative. Oh, sorry, I make a mistake. So sorry. Derivative 1 to -1 is equal to like according to the function, and we can get 2 minus 1 times 3 at 1 minus 1, 6 root over 6, and minus 1 at 2, 6 root over 6. Okay, sorry it's a little ugly, but we can get the function is here, and finally that's equal to negative 2 6 root over 3. So that is the final answer, and I think this question is actually 0 in our exam number 2, and I have some tips for you guys. Let me use eraser to get it off. And the first thing is that we have to find the derivative about the fx, fy, fz about the original function, and then we get the unit vector is equal to the vector over the vector's magnitude. Then we combine those two functions, we get directional derivative function x, y, z. Then we, because we have the point, this is the question give us. So we use a point to the function, and we get the answer. Yeah. And I want to use another example is also in the page 924, but the question number is 19. Okay, so quickly, the question 19, and we can see the question here. Oh, why I cannot? Now we can see the question is here. It's 19. fxy equal as xy, and the point is 0, negative 2, and the vector is 1 over 2, and times I add the 3 through j. Okay, so why I want to talk about this question, because I just want to show you guys the graph in the 3D. So I will directly give you the answer. So like the fxy is equal to x is equal to y, then fy xy is equal to x, and the unit vector is equal to is equal to 1 over 2 I at 3 squared over 2 j, and when we get the point, as we get point 0, negative 2 is equal to minus 1. Okay, so that's the answer. And I want to show you guys and now I want to show you guys the graph, and I already graphed that. Let's show you like this original graph fxy, and we get the derivative function is that one, so we can see it clearly. But the question is because when I made this homework, I caught this point, so I hope someone can tell me what's the next step, because I made the tangent plan, but it's wrong. Actually, I don't know why, so I hope somebody can help me. So thank you for watching my video, and I hope you guys can do better and than the exam 1 in the exam 2. Thank you.